Hey guys, this is Luke with Central Pennsylvania Reviews. I'm also the guy known as Retro Tech Rewind, associated with Central PA Reviews. Today I wanted to do a little video, hopefully the first in a long series of videos of just general repair, maintenance, even modifications of classic game consoles and arcade boards and stuff. Today we're going to be looking at a original Neo Geo MV1 board. This is a Neo Geo MVS board, obviously. It's the original model single slot. As you can see, it's pretty long. I've got an MVS cart over here that I can actually show you. And this is the size of an MVS cart, just for a little bit of size reference if you're familiar with these at all. Now, I got this from a gentleman on eBay, and the problem description was booting to green screen, just like a plain green screen, which if you're familiar at all with Neo Geo MVS repairs, that usually has something to do with the battery, the clock circuit, maybe even the backup RAM, usually, most commonly I should say. So, as you can tell, the board's not in that great a condition, but the main thing is it's booting up, at least it's turning on. You can go ahead and take this guy off here, if I can get it off. Let's see, there's quite a bit of battery corrosion on here. Let's see if I can't get the light to a better position so you can check that out. These batteries, they tend to leak, and when they do, it's not very pretty. As you can tell, there's a lot of good corrosion hanging on right there. There looks like someone did a little bit of a patch job over here as well. Guess we'll see what's going on here. I don't know how well you guys can see this, but I'm taking a look and I'm seeing a lot of these traces on here. They look corroded, and I'm definitely gonna have to check them out with my meter, especially right here. Those guys, I really don't have very high hopes for these guys here. So I guess we'll see. This particular model board is interesting because it actually has a switch to switch between stereo and mono, which if you're familiar with arcade cabinet wiring at all, there's the JAMA standard, which is a single speaker mono sound, typically three buttons for each player. The four directions for the joystick, but the MVS or Neo Geo wiring pinout, I guess you could call it, is actually wired for stereo sound, and you get 4 buttons per player. This little switch right here will actually let you switch between the MVS pinout and the standard JAMA pinout. Alright, so I got my Unibios right here. This is just a simple EEPROM with the Unibios program burned onto it. I like to pop these in, and it does have a pretty decent diagnostics menu and options that aren't typically available on the standard BIOS on a Neo Geo. So there is also, I have it separate over here, there is a standard Diag BIOS that a gentleman online created, and it does a more in-depth, specifically only for diagnosing problems and other issues you might encounter. But I mean, you can't play games, you can't test anything else on that. So we're going to go ahead and we're going to start taking a look here. I'm going to grab my meter, we're going to test some continuity on these traces here, because they're not looking too hot. I'm going to go ahead and turn my soldering iron on here. You can see that the solder mask on the PCB itself is actually just kind of flaking off. That's going to definitely need replaced. I'm going to clean that up a little bit, actually. And so what I like to do, best thing for battery corrosion is to actually have distilled vinegar. I don't have any at my desk here right this second, but that is the best way to neutralize acidic damage to a board. So I'm going to wait for this here to warm up for a second. But while I do that, I do want to investigate some traces that I saw on the underside of the board here. If you check these out, these right along this bottom edge here. I don't know how well you're going to be able to see that on camera, but it looks like that outermost trace is kind of corroded, looking kind of cruddy. So we're going to check that guy out too while I'm waiting for my soldering iron to warm up here. You can see these guys right here, they're connected right here on the opposite side, and that connects directly to the cart connector. Won't be able to tell specifically by looking. I can do the reading check on here to tell exactly where these traces are going, but I'd have to take the cart connector off or just run continuity on them. So if you look carefully and just kind of follow where these guys are going, looks like these are all data line. I would assume, yeah, this is going to the 2610. The Yamaha 2610 here. That's the main sound processor for all Neo Geo boards, actually. The main processor itself is the 68K. And the rest of these guys here are all custom chips for the actual Neo Geo itself. There's some other logic. There's some Sony 5814 slow or fast RAM. The slow RAM is this guy here. These are like the standard flat pack guys, and these are also notorious for failing on a lot of Neo Geo MVS boards and AES boards because they're very susceptible to over voltage. So, you pump anything over, well, I wouldn't say anything, but good chance if you put anything over 5 volts in there, it's going to fry it. So I see that a lot. Traced all the way over to the audio processor is this first trace right here on the cart connector. So I'm just gonna pin out every single one of these because all of these traces right here look a little suspicious. I don't really trust them. They look a little corroded, and it's corroded on the other side too. So it's always best to check. Alright, now that my soldering iron's heated up, I'm actually going to remove this little crystal right here, the oscillator here. I do have plenty of replacement parts. I'll do a pan shot, it's probably going to, by the time you're watching this, you're probably have already seen it. So anyway, flipping this board over, a lot of MVS boards have this weird foam padding under here. It's what's the word I'm looking for? The worst. It is awful. I hate it. I can't stand it. It just sucks, and it's awful to remove. It's awful to clean off. So I'm going to go ahead and just kind of fold this up and start cutting a little bit of this off so I can get to those pieces underneath. I will probably end up, in the grand scheme of things, just going ahead and removing this entirely, but for right now I'm just going to get a little piece off. Let's see, so looks like the traces are going to be about right here. I'm actually going to put a little bit of rubbing alcohol right here. That'll kind of soften it up. And I like to use a small flathead typically to just very carefully just kind of pull this gunk off of here. And anyone that's worked on an MVS board knows how annoying this stuff is. Chipping away at this slowly. You can really see, there's a decent amount of corrosion under there. Let's see if we can get the camera a little. You can see it's starting to clean up a little bit, and there's still a little bit of lumps. I like to try and get it as clean as possible. So mainly for visibility's sake, so I can actually see what I'm working on. Yeah, there's definitely spots of super glue on this. I couldn't really tell you why. I'm guessing these have a tendency to like peel up and dry out, and it looks like the previous owner just kind of thought, hey, you know what would be a great idea? Let's just go ahead and super glue this back down. Not a great idea. Fun fact. Alright, so this is kind of cleaned out a little bit, enough that I can actually get to where I want to be as far as removing the oscillator here. So I'm just going to kind of move some of my tools out of the way so I have a little bit more room to work here. Alright, so I got a nice Pace desoldering iron, and does a pretty good job. Heiko makes a good one. There's a whole bunch that you can buy out there, but this is just the one that I happen to own. Just get it in there. Get some of that solder out of there. Yeah, that's so corroded that leg actually just completely broke off. Unfortunately, this clock circuit for the RTC, which is the real-time clock, keeps the you know, your dip settings, various other settings for your board in check, and the battery sits right next to it, and it has a really nasty habit of leaking and just getting all over the place. As you can see, I'm pretty sure that guy's gonna be toast, so we can get rid of that. And as you can see, this is not looking like a fun time for this guy here. Yeah, there we go. So all these parts are pretty much going to just end up being garbage. I'm just going to pitch them. I do have another board, and I also do have, like you saw earlier, the bins with all my other parts in it. So what I'm going to do here, I'm actually going to remove quite a bit of these parts because they're all looking a little compromised from this battery corrosion here. And frankly, better be safe than sorry. Here, there you go. Sorry, I have this light that's got a ring of LEDs on there, so you can see all that corrosion. And actually, all these traces right here have no continuity over to the chip here, so we're definitely going to need to take a look and patch those guys up. So I'm going to go ahead and I'm going to remove these components here. I'll do it off camera in the interest of time. Alright, so I went ahead and took the liberty of cleaning some of this stuff up. You can see I removed rather, some of the components here. I wanted to check these traces that are going underneath here. Move the light up a little bit so y'all can see that better. But basically, you can see there was a ton of corrosion here. I removed these connectors. These actually connect to the credit displays on the control panel itself for the cabinet. And I removed the RTC chip. It's a, I want to say D4990, I think. You can see there's a lot of corrosion here. I tried to clean it up. I actually scraped it up with a fiberglass pen here, just so I can check out the continuity on some of these traces. Ohmed each one of these out, and all of these traces are actually bad right here. These actually connect underneath the board to the dip switches here, which control the test mode, you know, pause. Well, it's actually just a stop function that, you know, acts as a pause, I guess you could call it. But basically, all of them are disconnected right now. And they run to this chip right here, which controls some of the BIOS settings and stuff. So I'm going to have to patch those up. Surprisingly enough, all of the traces that go to this resistor pack here and the RTC chip are all intact. I checked each one of them out and actually read the resistance rating on each one, and they all check out very well. So I might patch them. We'll see how things go, but I am going to start trying to replace some of these components here. I have a scrap board that I pulled some off. It's actually another one of these that was completely dead that I ended up just using for scrap parts. I did replace or pull some of the parts there, so I'm going to go ahead and start replacing some before I actually patch up these traces. That's going to be a whole nother process. I'll probably use some of this just like 30 gauge wrapping wire here just to patch up the traces and see what we can get going. Then I'm going to go ahead and probably power it on and test it. I did also take the liberty of running this under the sink for a little while, cleaned it up a bit. I don't know how well you can tell. I mean, that's a little scratched up because I buffed it up with the, or scratched it up rather with the fiberglass pen, but underneath as well as I tried to get it a little clean. This is still a little dirty. I'm not sure what kind of residue this stuff is here. And funny enough, you can see here that there was actually some super glue residue here from somebody for some reason. Couldn't tell you why, but so I'm going to go ahead and replace some of these components here, and I'm going to start patching up the traces here and see where we can get from there. Alright, so you can see here, I actually went ahead and replaced the battery with a CR2032 holder that'll hold just a standard, you know, the button cell battery here. Also put a socket on this RTC chip just in case this one that originally came with the board in fact doesn't work. I got an extra one over here, so we'll see. I also got the crystal on here and actually soldered the ground strap here onto the actual casing. Replaced the two small capacitors here as well. I haven't patched up any of these traces yet. I'm going to eventually, but what I'd like to do now is actually test it, and I can actually show you guys how exactly it is that I tested my little test setup that I got going on here in my work area. So we're going to go ahead and plug this into the TV and see what we get. Hopefully we can get some signs of life. I'm not expecting it to play games or anything like that just yet. Obviously I haven't put this cart connector back on, but let's just see what happens.